What you're looking at is a computer-generated visualization based on real-time telemetry from Integrity. Currently traveling about 16,000 miles an hour. Integrity traveling about 16,000 miles an hour.
For the prop cautions, we're taking a look.
Copy that.
Now just about 5,100 miles from Earth. Splashdown scheduled 43 minutes from now. We're just 9.5 minutes away from the crew module service module separation. We are confirming.
Integrity, we are assessing details, but so far looks like a good hot fire.
Of the thrusters in advance of the crew module service module separation that's coming up just 8.5 minutes from now. This will begin the period in which we will have rapid fire succession of critical activities on board that will lead to entry interface just 28 minutes from now, where the vehicle will enter the Earth's atmosphere at an altitude of 400,000 feet. The time of entry interface, 6:53 and 30 seconds p.m. Central Time. Integrity's astronauts were awakened at mid-morning to begin their entry preparations. And propulsion officer now reports a good hot fire test in preparation for the crew module service module separation. We're now inside 41 minutes until splashdown.
Integrity Houston, we have confirmed a good CMRCS hot fire, and although we are not seeing GPS acquired yet, you can skip the troubleshooting steps in 157 for now.
Integrity copies.
That GPS discussion indicating that we will be acquiring navigational data for Integrity through the Global Positioning System equipment on board. We just don't have it yet, but we will. All of Integrity's systems are in great shape to support its high-speed entry into the Earth's atmosphere. It, once again, will reach a peak speed of 24,661.21 miles an hour.
You're calling GPS. We at least have GPS 1 looking good on board.
We are confirming.
The guidance, navigation, and control officer here in Mission Control confirming that we have good lock on GPS data. We are on a communications link now through the tracking and data relay satellite system. Now, following splashdown, we're going to lose that link and go to what's called a VLDR, a very low data rate communications link, so that we can talk to the crew inside Integrity as they are on the water.
Integrity, confirm we do see good GPS.
We do too, especially GPS 1 is accepting in nav channels 1 and 3.
That GPS data is basically telling Integrity's onboard computers its position relative to the Earth, but its trajectory and its orientation according to flight dynamics and the guidance, navigation, and control officer is spot on. We have now armed the pyros for the crew module service module separation coming up less than 5 minutes from now. Once again, just 10 seconds after entry interface, we will see Integrity reaching its peak speed of 24,661.21 miles per hour. That will be just seconds before we begin a 6-minute blackout period.
Integrity, Houston. Your vehicle is in a good config for CM-SM SEP and go for CM raise.
Houston, we see the same on board and copy go for CM raise.
That CM raise referred to as the slight firing of 19 seconds by Integrity's thrusters with a change in velocity of 9.9 feet per second, a slight nudge of the aft end of the vehicle so that it's tilted a bit upward, providing the final angle of attack as the vehicle enters the Earth's atmosphere. This being the mitigating factor that will reduce heat loads on the heat shield as we reach a point downrange from the start of entry interface, some 1,701 nautical miles to the splashdown site. Integrity systems in excellent shape. We are currently 3,300 nautical miles left in this mission. Splashdown scheduled 36 minutes, 39 seconds from now.
Integrity, Houston. For the 2 enabled prop cautions, what happened is while the thrusters were firing, multiple pressure sensors on each of the strings diverged a bit from each other. Those limits look to be set pretty tight. We think it could happen again when the thrusters fire in the future, so we are going to suppress those messages.
We concur with suppress, not inhibit. Thank you.
That exchange between Jackie Mahaffey, our Capcom for tonight, and Reid Wiseman aboard Integrity, indicating basically to ignore sensor data. All of Integrity's systems are in good shape. Now, coming up on about 90 seconds till the crew module, service module separation. All quiet here in Mission Control as we enter the most critical phase of the completion of this flight. All of the preparatory activities leading up to the vehicle entering the Earth's atmosphere just 21 minutes from now. Coming up on 1 minute. And we have confirmation of crew module, service module separation, and a great view, albeit momentarily.
Houston, good step on board.
Houston copies and concurs.
The European service module now separated from Integrity, a job well done.
Integrity, no action for the 4 CDH cautions. Those are SM related, not applicable.
Integrity.
So, with Integrity now flying free on its own for the remaining 32 minutes of this mission, next up, the raise burn, a 19-second firing of Integrity's thrusters.
GPS 2.
Integrity copies. Good GPS 2.
Coming up on the 2-minute mark until the raise burn. Again, this is the final tweaking of the orientation of Integrity to put it in the right angle, if you will, the angle of attack, the telemetry. This is the maneuvering of Integrity to the raise burn orientation. Just 2,800 miles from Earth.
Houston, we got a great view of the European service module out the window with the sun hitting the side and the solar rays and the NASA worm right there. It's a beautiful looking machine.
Roger.
And we have completed the maneuver to the raise burn orientation, 1 minute away from the raise burn.
Integrity, good. CM raise burn. Your flight path angle is within limits.
Is set and will not be amended any further, and we have the right angle of attack to mitigate any excessive heat loads on the vehicle during entry interface.
Integrity, Houston, a heads up about comm coverage. When you perform the 180 roll, for the first minute or so in that attitude, we expect about a minute LOS.
We copy.
So for those who are watching the series of events coming up, we will enter the first traces of Earth's atmosphere 14 minutes, 45 seconds from now. 6:53 and 30 seconds is what is pegged for entry interface at an altitude of 400,000 feet, traveling at approximately 34,800 feet per second, range to touchdown or splashdown 1,701 nautical miles. 24 seconds after entry interface, we will enter a 6-minute blackout period in which we will lose communications with the crew. This is expected due to the buildup of plasma around the vehicle. That's an ionization effect due to the collision, if you will, of the velocity of the spacecraft with the friction of the Earth's atmosphere. That 6-minute blackout is expected to begin at 6:53 and 54 seconds p.m. Central Time. During that period of time, we will reach our peak speed of 24,661 miles per hour. That comes just short, based on unofficial data from the flight dynamics officer right now, will come just short of the velocity record set by Apollo 10 of 24,791 miles per hour in 1969. We expect peak heating on the vehicle at 6:54 and 52 seconds p.m. Central Time, a minute and 22 seconds into entry interface. At that point, we will be just 204,000 feet above the Earth, traveling at 33,000 feet per second. The blackout period is expected to last 6 minutes. We expect that blackout period to end at 6:59 and 55 seconds p.m. Central Time. From the end of the blackout period until splashdown, it is just 7 minutes, at which point we'll start deploying the series of parachutes to slow integrity down to an ultimate splashdown velocity of just 19 miles an hour.
We see the same, waiting for the 180 rolls.
The parachute deployment sequence, once again, will come in several segments, but in rapid fire succession.
And we have a great view of the moon out window too. Looks a little smaller than yesterday.
Guess we'll have to go back.
Reid Wiseman and Jackie Mahaffey exchanging discussion on a view of the moon that Integrity's astronauts are seeing in the final minutes of this mission that will be completed with splashdown just 25 minutes from now. 3 forward bay cover parachutes will be used to pull the forward bay cover off the top of the vehicle. Then 2 drogue parachutes will be deployed to slow and stabilize the crew module during its descent, followed by 3 pilot parachutes that will lift and deploy the main parachutes from the forward bay. The final sequence will have 3 main parachutes deployed. These will be 116 feet in diameter, each main parachute approximately 265 feet long when reefed. The parachutes will ultimately slow Integrity down from its peak speed of almost 33 times the speed of sound to a gentle 19 miles an hour at splashdown. The vehicle is now currently in a roll to the proper attitude for entry interface. Our trajectory is right on according to flight dynamics.